Uh, Morning, Michaels.
Good morning.
Yeah, Michael Schill, thanks for joining the call. I wasn't. This is the first time doing the Zoom version of this meeting, so I wasn't sure if there would be, anything special I'd need to do. So appreciate that.
Not so it should be fairly simple.
Okay. One quick question while we're waiting for folks to join. Um, I'm assuming you hit the record button already, but I'm assuming it's going to be similar to how GoToMeeting was. There's a pretty intuitive way of, okay, just hit this button to start recording the meeting.
Yeah, actually, John, it's even simpler than that. I think Kevin has it rigged to start recording automatically.
Oh, okay, gotcha. And that's effectively foolproof or John-proof.
Oh,
So, good,
hopefully,
yeah, yeah.
hopefully. Um, John, I apologize. I am double booked for this time slot, so if you're good to go, I'm going to drop off. But give me a shout if you need anything.
Okay, thanks so much, Michael.
But thanks, guys.
Hey, Juan Carlos. Just waiting for others to join the call.
Hi, John.
Hey. I see DM. I'm not sure who that is. Is that you, Don?
It is me. How are you? Can you hear me?
Good.
Hi, yes.
Yeah, as always, we'll give a few minutes for folks to join the call. So please hang on.
Hi, morning, everyone.
Hey, morning.
Hi, Thomas.
Hey,
Thomas, long time no see.
yeah, it's true. It's been a while.
Yeah. I assume you'll be at the summit.
Yeah, absolutely. Yeah. So would be great to meet you guys all there. For those who were there, I think Juan is also there.
Yeah, it would be good to see everyone. Let's just give another minute. All right, it's 9:05, so I think we can get started. Thanks all for joining the bi-weekly Dohe Exchanger call. We have a few items on our agenda today. I assume everyone can see my screen.
Yes.
Yeah, we can see it.
Yeah.
All right, awesome. So so we are working towards the submissions for the 2023 OCP Global Summit. We are actually a little under, we are actually exactly a month away from the event. So at the end of last month, we had submitted a few slide decks for presentations under the cooling environments track. There should be an email going out from Kate that will be sharing feedback from the cooling environments leads. And the deadline for submitting the final draft is at the end of this month. I believe it's the 29th. So just want to highlight that to our contributors. For the ACS Dough Heat Exchanger project updates, Juan Carlos, I had a quick chat with Jabari about this yesterday, and we're going to make a few adjustments to the slides, and then there's something that maybe we want to talk about later on the call. That could be something that can be added to the slides as well. With the densifying modular data centers with hybrid cooling, I've been having weekly meetings with Carl and David. Our goal is to have those slides finalized by the end of this week. And the reason for that is because that will give adequate time for us to kind of do our internal checks and get the slides approved for presentation at a at a public summit. So if that's a requirement in your organization as well, please plan accordingly. And let me know how I can help over here, expedite anything. With the aluminum microchannel heat exchanger, Sankar and I, actually Sankar, Danfoss and Boyd have helped sort of put those slides together, and they'll be presenting it. I do want to pose a topic for discussion with the community to maybe add another slide that may help paint a clearer picture, because right now it's coming along pretty well. Kind of focusing on what do microchannel heat exchangers bring to the table. We have a pretty nice summary, but in terms of applicability in the data center, or just application in general, it might be good for us to have a discussion over here and come up with some key points we could then filter into a separate slide that sort of talks about, okay, it looks like a pretty interesting option, but what about in application, right? So we'll touch on that in a little bit. And then with regards to the frame-based deployment of Dough heat exchangers, we've already sort of filtered the feedback internally on the Meta side, and we're working on that currently. And Juan, who's on the call, is a part of that. So for folks who are sort of helping put this material together, just want to reiterate that September 29th is the deadline for submitting the final slides. And if there are any questions related to that, or if you guys require any help, please let me know. Any questions or comments related to that?
No questions. Thank
Okay.
you, John.
All right. So moving on to what I just brought up with the aluminum microchannel heat exchanger, I wanted to solicit this forum or this group for input on what would we say would be the high level considerations for enabling an aluminum microchannel heat exchanger as part of a Dough heat exchanger solution. And basically in application, and then, this could be in application with a facility water loop, which is, the more predominant, I would assume, is the more traditional use case of a door heat exchanger. And then potentially also the TCS loop, which could be, maybe you'd like to put a CDU in between the door and the facility, or maybe it's an hybrid solution where, the door heat exchanger and the cold plate loops in the hardware work together to, to push the liquid cooling in the rack close to 100%. So when we talk about implementing a microchannel heat exchanger, what are some thoughts that come to mind for the community here to take into consideration? And maybe we can start with a microchannel heat exchanger in a door heat exchanger application in facility water loop. What would be some things that would need to be highlighted or addressed or considered?
Yeah, John, the first is the corrosion. Usually the quality of water of the facility water is not known as something we cannot predefine, because every data center is different. And sometimes it's also copper a problem because of corrosion, and we have to go to stainless steel.
Okay.
And this is because of the quality of water. If the quality, for example, we are using propylene glycol or something or similar with inhibitors, maybe it's aluminum an option. If not, we have to consider the quality of this water, the amount of air in the system, oxygen, better said, because they produce corrosion, and the aluminum, and we have to consider this point. I think this is the most important point: corrosion and compatibility with the facility water system.
Yeah, I agree with Juan. Most facility cooling water loop does not treat for aluminum protection. So if we use facility water to cool the microchannel with aluminum, they need to have aluminum corrosion protection. And they need to try to eliminate any contribution of the suspended copper, because the copper actually will play on the aluminum surface, cause galvanic corrosion.
Okay. Thank you. And in relation to quality of the water, I also assume that facility water, my assumption is that it's less controlled from like a particulate size standpoint. Would that be a concern also with facility water, since we're talking about microchannels here?
Yeah,
I mean, in
and on
comparison
the
to the
channel,
incumbent solution, which is fin tube, but the fin tube, the copper tubes usually are, on the order of millimeters, right? It could be 4 millimeters, 5 millimeters, 6 millimeters ID. But this aluminum microchannel, even though we're using the term microchannel, but it's sub-millimeter. So would that also be a concern?
yeah, I think they need to have some side stream filtration to control the particle size. I would recommend like below 10 micron to give you the best quality of water.
Got it. Okay. So in general, filtration to control particulate size. Awesome. Anything else comes to mind?
I think this is the most important point.
Okay, so just talking in general, the quality of water can mean so many things. So got it. Yeah. Let's move on to the TCS. Actually, before we move on to the TCS, or maybe as part of talking about the TCS, because I usually assume that a facility water loop would be water-based, but I can also understand that it could be, it could have glycol. It could be a glycol water mixture, depending on where the facility is located. But what I do know is with the TCS, right, it could be water or it could be, propylene glycol water solution. Since we have talked specifically about water before, or at least that's what I've captured here, do we see any concerns with aluminum and a propylene glycol water mixture, or is that less of a concern? Sorry, this is just an open-ended question to those on the call.
Using propylene glycols or similars, usually you have inside as well inhibitors. But doesn't mean that this is no problem. At least you have to consider how many substances or materials are inside the water, for example, copper or other materials, and how the main surface of all materials. For example, microchannel have a very large surface which the inhibitors had to cover in order to avoid corrosion. But in any case, you have to control the water quality in any case, because sometimes open loops produce also corrosion. For example, oxygen into the water will produce also corrosion, and open loops or closed loops or loops in which the air is going on will be a problem. So with TCS loops, we have less problems using inhibitors and propylene glycol, but in any case, the design of the system is very important. The number of materials, which materials are there, and yeah, I think this everything we have to consider some points there, but this is less critical than with only water.
Got it. Yeah, and I mean, I'm a hardware guy, so I'll hold my hand up, but I would assume that the likelihood of copper in a facility water loop is less. I mean, and please correct me, compared to TCS, right? Especially if you're using a Dau heat exchanger in conjunction with, in the same loop in series or in parallel, doesn't matter, with liquid cooling in the hardware, right? Because then predominantly cold plates are made out of copper, right? Because you want the best performance. So I would say the concerns with galvanic corrosion, at least in a sense, are maybe more accentuated in the TCS loop potentially, or is that would that not be the right point to make over here?
Yeah, this is the point. If using closed systems in which air is not going on in the system, and propylene glycol with inhibitors, we will prevent the aluminum to be corroded by the ions of copper. So since the quality of water in the TCS loop is much better than in the facility water system, this will be not as critical as in the facility water. Also, if we have copper in the cold plates, and I think the copper cold plates are also protected with some I don't know what is the name of this process to prevent that the copper ions are going into the loop. So this is passive iron. I don't know. They make passive.
Use azo-based corrosion inhibitor to chelate the copper.
Yeah,
So
yeah.
the cold plate will be passivated and protected.
Passivated. Yeah.
Yeah.
Thank you.
Sorry, passivate, the cold plate surfaces. Yeah, and I think that's pretty standard in the in like PG25 that you can purchase from multiple vendors. So
Yeah.
the azole and the phosphate based inhibitors. Got it. Excellent. Anything else we want to call out? This is really good. I'll be able to kind of create a slide based on this, because I want to make sure that this is addressed. In order to make sure we, because this is the inevitable question, right? It's like, yeah, aluminum looks great, but like, what does it mean from an application standpoint? So I just want to make sure we're kind of calling out the obvious points at the very least. Thanks.
Mhm.
Before we move on, is there anything else in general on this topic that should be called out as part of the slide deck? Please let me know. Okay, great. Moving on, one thing I did want to touch on is potential focus areas for this sub-project moving forward. And by moving forward, I mean beyond the global summit, and once the white papers that are currently in work get contributed. I know, Juan Carlos, you had previously brought up a point along the lines of defining maybe the fluid and electrical interfaces for all applications of a door heat exchanger. I know you had also said that there might be certain nuances that the general industry needs to understand, which is, let's say you have a hybrid cooling solution and a door, and the fluid comes in through the door first and then maybe goes into an in-rack CDU, and how that might be maybe a little bit more complicated than people assume.
Yeah.
But I was just wondering, like, can you maybe help elaborate on, maybe at a high level as to what all aspects should be addressed, and basically how should we kind of form or basically formulate this effort?
Yeah. Maybe the first consideration we have to do is, if we have something between the rack and the rear door, so like a frame to be able to connect everything in a proper way.
Okay.
I don't know if it's fixed to use a frame for the rear door, or we can attach the assembly the rear door directly into the open rack V3. But this is one consideration we have to do. Second, we have to
So
define.
basically a mechanical interface. Got it.
Yeah.
All right, keep going.
Yeah. Second is to define for everyone which are the cold and the warm manifold. This is very important because we have to connect in a proper way everything to be able to use the CDO with a traditional rear door in the hybrid mode or in a air-assisted unit.
Okay, and then so these would be fluid interfaces, is what you're talking about.
Yes.
Okay.
What is cold, what is warm. And
Okay.
once we fix it, this.
Sorry, and when you say what is cold, what is warm, and depending on which side the door hinges, your connections between the door and the manifolds would have to work accordingly, right? I think that's what you're talking about, right?
Yeah, and also the manifolds. The manifolds, there are one side is cold, one side is warm, and we have to define for everyone which is warm, which is cold, because if not, it will be really difficult to speak the same language.
Okay, so then it would also depends on which side the door hinges on, right? Because I was assuming one might be easier than the other, or one might be more difficult, right? Depending on how we define the cold and hot manifold locations.
Yeah. I don't know if we have a standard for the manifolds cold on the right.
I think we have a recommendation. I wouldn't call it a standard. And I think that would become clearer with the BlindMate, with the ORV3 BlindMate preliminary design reference document that will be published. I think before the global summit. So we can probably look at that and then refer to it and then say, hey, this is the reference point and it's defined through OCP.
Yeah, will be fine. Yeah, and once we have that, we have to consider, okay, we have the rear door, we have the connection with the CDU or FPU, whatever, the connections to the manifold, how to bring out these hoses from A to B, which way we want to follow. I think it is something we should maybe not define, but give some ideas to do that in order to do.
Evaluate the feasibility, right? It's like, okay,
Yeah.
it should be doable, and okay, here's a reference point that we are suggesting, right? And it's up to the end user whether they want to take that and modify it or do their own thing. So yeah. Okay, so then how do I guess we can call it the rack level
routing
terminations work, right?
Yeah, okay, yes.
Or are laid out. Yeah, just help me. I mean, I'm just putting notes down. We can continue to work on this with Jabari, and then maybe formally bring it back over here.
Yeah, okay.
Anything else? Do we need to worry about power communication, or would that be a little too detailed then?
Okay, to connect the rear door to the bus bar, there was 1 year ago we spoke about connectors to the DC bus bar in some way to connect the rear door.
Okay, I'm just going to say potential. Just say power and communication. Power and communication from the Open Rack V3, because power can be a connection from the bus bar, as we talked about. So that would give you 48 volts DC. And then communication could be something like an in-rack management module. I don't know if the the hardware management group is working on something like this. And Mike, don't mean to put you on the spot, but are you aware of something that could be within OCP that could be leveraged here?
The liquid cooling hardware management group is working on adding additional definitions for what the Redfish interface to the rear door heat exchanger would look like. So the work that we did a couple of years ago needs to be updated.
Okay. But in terms of actual, I guess the point I'm trying to make is in terms of an actual hardware, like hardware-based rack management module, is that something that's being worked on, or is the focus more on? Is the focus?
There is a definition of a rack manager.
Okay, rack manager. And do we know who's working on this? Is it John from Intel or?
Yes. Yep. It's John Leung.
Okay. Yeah, maybe we can look at what they are working on and if it's been published yet, but maybe we can use that as reference. Otherwise, we can keep yeah, we can keep the communication options open. But you know, if it's stuff that's already being contributed through OCP, it's a good opportunity to kind of show, hey, here's all, you know, all this neat stuff that's being done through OCP and how it all comes together. So yeah.
Yeah, for the redfish management in general, there is a base document that again John's managing that has the definition of the interface to any OCP device. So the rear door heat exchanger is part of that. So that's the minimum things that we would have to have. Then the liquid cooling hardware management group is got another base spec that they're working on that says any cooling device also has to have this additional set of interfaces. And then on top of that, there's yet another definition that would be just for the rear door heat exchanger that would have liquid cooling management interfaces that are specific to a rear door heat exchanger. So when we did the rear door heat exchanger redfish profile a couple of years ago, a lot of those other documents weren't fully cooked or didn't exist at all. So there's probably a lot of things that are in the current version of the redfish profile for the rear door heat exchanger that we can take out because it's included in other base documents.
Okay, cool. And then all the necessary, I guess, yeah, basically all the necessary sensors and everything have already been, yeah. I think if it's an overall liquid cooling hardware management profile, then I believe all the necessary definitions should be there to cover the door heat exchanger use case. Yeah.
Well, there's actually two. There's a base one that all liquid cooling devices will have. And then on top of that, there's specific profiles for a CDU or a rear door heat exchanger or any other device like that.
Oh, nice. Okay, cool. So
because the CDU is a lot more complex than a rear door heat exchanger. So there'd be overlap between the two because you'd have inlet temperatures and outlet temperatures for mostly facility water. But there's a lot more controls and sensors in a CDU. So the profile for a CDU is much more complex than the one for a rear door heat exchanger, even though they would actually have a lot of overlap.
Got it. Thanks. Okay. Sorry, Juan Carlos, going back to you, anything else that should be included as part of disambiguating the door in use with OpenRack v3 that we should focus on?
Yeah, maybe the connection from the bottom to from the top.
Right, got it.
Open the door from the right, from the left.
Yeah. So top and bottom connection options. Got it. Yep. Good one.
I have a question on the branch line supplying these. Is there expectation of balancing valves being required, or is that functionality entirely performed by components inside the door heat exchanger?
You mean like a PICV?
Yes.
I mean, this is just my take. I'll let others chime in too. My assumption is that the PICV would be a part of the TCS or the FWS loop. So in a sense, it would kind of fall beyond the domain of the rack or the door heat exchanger.
Okay.
Yeah.
That's consistent. I didn't know if there was any way you were trying to spec it to be integral to the door heat exchanger itself. So.
Good question, Don. All right.
Is there been one other question? Is there discussion on is there a one diameter feed size, 1 inch or 1.5 inch that's most common, or is that something that's being left open?
So in the requirements, the door heat exchanger requirements document that was contributed a while back. The recommendation was made for an inch, but we also left it open in case, you know, folks wanted to look at higher capacities. So the reference point was an inch, but, you know, it could be an inch and a half depending on, you know, what you need. Because let's say, for example, you have a door heat exchanger in a hybrid application. And by that, I mean the door is only one part of the rack loop, right? Maybe there's an in-rack CDU, or maybe the door connects directly to manifolds that then supply cold plates in the hardware. Then the flow rate is just a function of how much liquid cooling you need to provide in the rack, right? And then, you know, obviously you wanna manage the pressure drop and the velocities and so on and so forth. I think then that would have an influence on, you know, what sort of connection sizing you want to have here. But I think the 1 inch is maybe a good reference point. But then again, I'm not a door heat exchanger vendor. I'm, you know, I'm a rack hardware guy on the hyperscaler side.
You
So
are
the
right,
nature of the
John.
question. Go ahead.
You are right, John. We have to consider as well the maximal flow rate on the rear door, and 1 inch is a good number for everyone. But in case the flow rate increase a certain value, the pressure drop will increase a lot, and we have to go to another dimensions of the connector.
Yeah. So for higher flow rates, may consider larger size.
Yeah.
Got it.
One of the questions is we look at deploying thousands of these items, and increased deployment is whether or not a common branch line is of use to IT cooling solution sets, and the trade-off between 1 inch being sufficient and 1.5 inch potentially being more universal. What are the trade-offs there? Is it just a cost issue, or is there performance issues that degrade when you look at 1.5 inches? Does that make sense?
Yeah, I mean, there's a trade-off involved. I mean, I can understand, you know, that on the facility side, you know, that's a long-term investment, right? And I think it kind of comes down to the end user. What they want to do is, if they want the flexibility because they anticipate, you know, rack powers increasing significantly over time, then it might make sense to supersize, I guess, your and I don't know how you're defining branch lines here, Don, but I'm assuming it's the tee off to each individual rack. Then yeah, then that's a trade-off you need to consider, because then you need to supersize your tee, the ball valve that goes on that, and then anything else in the valve train that you may want to put in there too, right? So yeah.
Okay, just a question, and if it just boils down to economics, then that's an area that we could look at as well, letting customers decide whether or not they want greater adaptability, or if they getting the most cost effective at day one is the best idea.
Yeah,
So.
it depends on what I don't want to use this term, but it depends on what freaks them out, right? It's like if they are less concerned about CapEx, which is, let's be honest, CapEx is always an important point, but yeah, it's just a trade-off at the end of the day and what the end customer wants. So yeah,
sure.
Thanks, Tom.
Thanks.
Okay, we have about 20 minutes left. Do we have any other topics we'd like to bring up? If not, I'm happy to give everyone time back, and I'll follow up with the presenters to work towards the deadline of September 29th. But anything?
Not from my side.
All right. Thanks all. Sorry, Jabari, were you about to say something? I see you unmuted yourself.
I was going to say, no, I'm not. I can't think of anything else. I was going to say then when Carlos spoke, so.
Okay, awesome. Thanks all. And see you all in 2 weeks. Thank you very much.
Well, thanks.
Yeah.
Thank you. Bye bye.